This video is on ions in aqueous solution. So we're dissolving things in water, and we're going to look at how to write dissociation reactions. So if I associate with someone, we hang out. If I dissociate, that means that we're going to separate from one another. So basically what we're looking at here is a way to write a chemical reaction that represents water getting in between the ions of an ionic compound as it dissolves it and separating it into its ions. So let's look at a couple of examples. So the first one that I have is if I take NaCl as a solid, and that's what that little S means there in parentheses, and I'm going to put this in water and see what it separates into. Now, we've looked at this enough times to know that sodium is going to separate into sodium ions and chloride ions. Now, this AQ here beside each of those means that it's floating around in water. It is an aqueous solution as opposed to a solid. And we just put water here above the arrow and not as a reactant because they're not forming something new. Water's just getting in between these ions, so water's the cause of the ionization. Now, this is a chemical equation. It is valid. It's just one that we haven't written before because these are ionic or ionization reactions, another word for dissociation. So we're showing how it splits into its ions. So you should have charges over here since these substances or pieces will have charges as they dissociate. Now, it can also be balanced. And if I put 1 mole of sodium chloride into solution, I get 1 mole of sodium ions floating around and 1 mole of chloride ions floating around. So for every 1 piece I put into solution, I get 2 pieces floating around. Now this becomes important as we talk more about colligative properties. And these properties are things that we're not going to go into too much detail here in this class, but they are properties that you will run into in your everyday life. And they are dependent on how many solute pieces there are. So that's the reason for this part here. Now let's look at another substance, calcium chloride as a solid. If I were to put this into water, it is going to split into its ions. Calcium chloride is made up of calcium ions and chloride ions. And it just so happens that it's 2 chloride ions. So notice here on this side, I didn't put Cl2. We're not forming, this is not, again, a chemical reaction. We're not going to be forming a chlorine gas or anything like that. We're just showing how this ionic substance splits into its ions because of that polar water getting in between. So it splits into calcium ions and 2 chloride ions. So for every 1 piece that I put into solution, I get 3 pieces floating around, 1 calcium and 2 chloride ions. So this calcium chloride would have a greater effect on those colligative properties. All right, so I have, on the next slide, I have 3 substances, and I want you to try and draw those ionization or dissociation reactions. Remember, your products should have charges. Now, one of the ones that I am going to have you do involves a polyatomic ion. You're never going to bust up a polyatomic ion. It is one of the ions that is liberated when we dissolve something in water. So give this a try here. You can pause this video and then restart when you get done. Okay. So here we have those substances. I'm going to show you how they do separate into their ions as we put them in water. Potassium iodide splits up into potassium ions and iodide ions. We want to make sure that we put a plus in between those. And to be totally accurate, these would both be ions in aqueous solution. So we put an AQ there. This next one is sodium nitrate, and it is going to split into sodium ions and nitrate ions. Again, you'll never bust up a polyatomic ion. And remember, you do have a list in your reference tables. Now, again, these would be aqueous ions floating around in solution. There. Magnesium chloride is going to split up into magnesium ions and chloride ions. But how many chloride ions? Well, there are going to be 2. So you can kind of look at this like balancing a chemical reaction. It's made up of these ions. I've got 1 magnesium, 1 magnesium. I've got 2 chlorines, so I need 2 chlorines here. Again, these would be in aqueous solution. So this is another one that for every 1 piece we put in, we get 3 pieces floating around in solution. I'll show you another one. This is a big one. Okay, if I were to put aluminum sulfate into water, it's going to split up into aluminum ions and sulfate ions. Again, with their charges there. But how many aluminums? Well, that would be 2. And how many sulfates? That would be 3. So for aluminum sulfate, for every 1 piece I put in, I get 5 pieces floating around in solution, 2 aluminums and 3 sulfates. All right, so those are dissociation reactions or ionization reactions, just showing how these are going to interact with water in order to ionize. Now, there will this is an important piece of chemistry, knowing how these things split up, and does play a pretty major role. It's not something we're necessarily going to go in right now, but this is an important skill to know how many pieces and what ions something splits up into as it dissolves. Okay, next we're going to look at kind of combining 2 of our skills that we've learned. The first one is predicting the products for a double replacement reaction, and most of these will be double replacement, but we've got 2 compounds here. And then using those solubility rules located in your reference tables to identify a precipitate. A precipitate is an insoluble compound, so water can't get in between the ions, so it stays together and will sit at the bottom of a reaction vessel or whatever. So these would be 2 aqueous solutions, and when they get together, they are going to form a precipitate. But we need to first figure out what they're going to form. So our strategy for this is we're going to take our first things, lead, and in this case, this is lead 2 because that's where that 2 came from, and sodium. Now, these don't want to bond together. They're just our first things. And then we're going to switch their anions. So what they're bonded to. So lead is no longer going to be bonded to nitrate. It's going to bond to chlorine. And sodium is no longer bonded to chlorine. It is going to bond to nitrate. Now, again, I didn't bring over this 2 because that 2 belonged to lead. I just bring over what a nitrate is. And so I end up with lead 2 chloride and sodium nitrate. Then we want to balance because we can't help ourselves. So 2 chlorines, so I'll put a 2 here. I have to put a 2 there, and that fixes it all. All right, so this is something we've done before. The only added step that we're going to do next is find which of our products, and you only have to worry about the products, is going to be our precipitate. So we're going to look at our solubility rules, and first we'll look up this one, which is a chloride. All chlorides are soluble, except if it's bonded to silver, lead. Oops. That's lead. So this is my precipitate, and you just underline it. That means it is insoluble. We look at the next one because you want to identify both. This is a nitrate. All nitrates are soluble, and there are no exceptions. So this one I'm not going to underline because this would totally split up into its ions. Okay, so again, we're just combining two things, completing and predicting products for reactions and identifying insoluble compounds. And in this case, we're going to be identifying our precipitates. So let's look at this one. I'll give you guys one to do. Okay, you can go ahead and pause this video and see what you can predict. All right, so our strategy with this one is we're going to take our first things and we write them up here with their charges, not K2 because that 2 came from carbonate. Ca is in group 2, so it likes to be at 2 positive. Then they're going to switch anions. And so potassium is going to be bonded to carbonate. It's going to bond to chlorine. And not Cl2 because that 2 came from calcium. And calcium is not going to bond to chlorine, it's going to bond to carbonate. If you don't remember your polyatomic ions, look them up. They're in your reference tables. So this is going to be KCl and calcium carbonate. That's what is formed here. And then we're going to identify our precipitates. So the first one is a chloride. All chlorides are soluble except if it's bonded to silver, lead, and mercury. Nope, that's something in group 1. It is soluble, so it would split up into its ions. This one is a carbonate. So all carbonates are insoluble unless it's bonded to something in group 1 or ammonium. Calcium's neither of those. So that's my precipitate in this one.